Looks
Yep.
good.
Yep. There you go. You're all set. So
Great.
thank you, Dr. Kalscheur.
Thank you, Jerry, for that introduction. I am a research animal scientist trained as a dairy cattle nutritionist with the U.S. Dairy Forage Research Center here in Madison. Forages is what I work on. So this is right in line with the type of research that I'm conducting. And I'm excited to be with everybody today to explain some of the research that we're doing here at the U.S. Dairy Forage Research Center. Um, just a little bit of background, and I know there'll be others here that will explain more on the agronomic side, but just briefly, my outline is a few reasons on agronomic reasons why we include cover crops. Then I'm going to discuss primarily the feeding studies that have been previously conducted and that are being conducted, evaluating cover crops and dairy cattle diets. And lastly, and briefly, a little bit on conclusions and future potential of cover crops and dairy cow diets. So first, and this is extremely brief, and I think Dan will go into much greater detail on this. Why include cover crops? Well, there's a lot of agronomic reasons, and just briefly, a few are that we can recover and retain residual nitrogen in the soil following corn harvest, which can be very valuable. And it's useful in the uptake of excess nutrients from fall manure applications, utilizing it for spring growth. And there's a lot of other reasons associated with soil health. But ultimately, for us, for me as a dairy cattle nutritionist, it's also valuable as providing supplemental or emergency feed sources for livestock. And that's really the direction of what I'm going to be explaining as a dairy cattle nutritionist. So what has previously been done for feeding trials? Amazingly, when you look through the literature, there's very few published studies evaluating cover crops in dairy cow diets. So I always learn a lot when I get out and talk to producers because producers have been using cover crops actually for quite some time already. And so a lot of the work that's been done is in the field. But when we look at the literature on what's been done, there are a few studies that have evaluated annual cereal crops as forages, but as a main crop rather than in a double cropping system. So when we look at fall planting, spring harvest, there's really one study that comes up, and it was conducted in Pennsylvania and published in 2017. And in this particular study, they evaluated the inclusion of wheat and triticale silage in the diets of lactating dairy cows. And they were planted in the fall and harvested in the spring at boot stage, much like we are attempting to do in the newer studies that we'll explain. In this study, they included the cover crop silage at 10% of the diet, replacing corn silage. So the main objective of this particular study was to determine if the cover crop silages can replace a portion of the corn silage without detrimentally affecting milk production. So as a nutritionist, I always like to put up diets. I think it's important to understand what's happening with the diet because ultimately this is what it all goes back to and how cows respond to these particular diets. So when you look at this, and I'll just briefly go over this, is this was done in Pennsylvania, high corn silage based diet, 44% of the diet, not much alfalfa, about 8% across the board. And when you look at the ingredients, other things are somewhat common. They did use cottonseed hulls, which aren't super common, but they are available. A little bit of hay straw mixture at 5%. But when you look at primarily the forage is corn silage. So they in this study designed it to replace 10% of the corn silage and the triticale and wheat silage was increased, and everything else was identical. So when you look at ground corn and soybeans and canola meal and soy plus and molasses, those are all equal across the board. So if you think about, well, if we're taking out corn silage and corn silage is predominantly forage and a starch source, and you're replacing it with something that doesn't have as much starch, then we're really changing the formulation somewhat. So be cognizant of the when you replace something, what is it that you're taking out? So when we look at the compositions, and this is the consequence of taking out corn silage, is that protein goes up in the cover crop diets because there's more protein in triticale and wheat. I think these diets, these forages were maybe about 16% crude protein. And whereas corn silage is typically 7, 8, 9%. So crude protein goes up. Amazingly, NDF didn't change all that much. It was all around 33 to 34%. And so this really wasn't so much a NDF experiment as it was a starch experiment. So starch, they already started at fairly low levels. We typically see starch levels much higher than 22.7% here in Wisconsin, typically 26, 27, 28% starch. So we have a fairly low starch diet, and then they took out starch. So when the triticale and the wheat replaced corn silage, starch actually declined from 22.7 to 19.3. And I think that's invaluable to remember when we look at the results. So what did they see? Well, amazingly, when you think about adding more NDF, you'd think there would be a decrease in dry matter intake because of rumen fill, but consequently, intake didn't change. It was actually about the same, right at 60, 61 pounds per cow per day on a dry matter basis. This would probably be about 120 to 130 pounds per cow on a wet basis. If you think about the moisture that's added, diets are typically like around 50% dry matter, give or take, maybe 5%. So quite a bit of feed they were eating. This is pretty normal. When you look at milk production, however, the corn silage-based diet, cows are averaging about 94 pounds. And on the two cover crops, it dropped about 3 pounds. So intake same, but milk production went down. And that was primarily due to a decrease in energy in the diet because we had less starch. So when you look at the milk divided by dry matter intake, that's a feed efficiency, which is how much milk is produced per unit of intake that the cow consumes. You can see that that decreases with the cover crop at 1.55 and 1.52 versus 1.61. And that simply means that, per unit of feed that they consume, they produce less milk. So when we look at composition, that was actually pretty similar. Like milk fat didn't really change much. Milk protein actually did decline a little bit, 2.65 versus 2.80. This is true protein. Low numbers. I mean, now we see much higher numbers on these, but this was also done in the, probably about 10 years ago. So things have changed over the last 10 years on milk composition. And then milk urea nitrogen, I'll just mention that it doesn't surprise me at all that they were higher, and that's a direct relationship of greater crude protein in the diet. If you recall, they were about 17.2% for the cover crops compared to about 16.2 for corn silage. And as a result, if you feed more protein, typically MUN increases. And that's well established. And that followed that in this particular case. So from that study, I look at it and I say, okay, that was really a starch-based study. What other things do we need to know? A lot of people, when I talk to them, are you in the rye camp or the triticale camp, or are you feeding other kind of mixtures? There's really no direct feeding comparisons of rye versus triticale. So when we are talking to others in our building that are working on the agronomic side, there's quite a few smaller pilot projects looking at plot work. And the question is, well, should we look at combinations? The reality is we can do lots of combinations in plots. But when it comes to feeding trials, because of the sheer number of cows we need and just the logistics of feeding cows, we're really limited to about 4 or 5 diets. And so we had to kind of decide, well, which ones should we focus on? And I'll come back to that in a minute. Then other questions are when to harvest. For milk cows, we want a high quality forage. So we're looking at harvesting primarily at a boot stage. And this will give us more of a high digestible, lower fiber forage. Fiber is really important and we need it to be high, and that will be more optimal for a higher quality to support milk production. For dairy heifer, however, we don't want those animals to get over conditioned. So we generally harvest a little bit later, probably between heading and doe stage. And this will allow for a higher fiber, lower energy forage, which is ideal for growing dairy heifers. And then how much should we include? I talked about 10% on the previous study. This is really a great question because there isn't a lot of research looking at how high of a level we can include. So we know that at 10%, pretty safe, I think, for all stages of lactation. We're looking at pushing that envelope. When I conducted our study, we wanted to go greater than that in a mid-lactation, but in early lactation, we probably want to stay more at a safer level. But I think if you have really high quality forages, we can even push at a higher level. And in cases where we need emergency crops, I think 15 to 20% is possible, but we'll talk about that a little bit more. And then, of course, the question is, what should it replace? What should we take out? And I think all of these studies, it's as important what you're taking out of the diet as it is what you're putting in. And so I'll talk about what we chose to do in our upcoming experiment here. When it comes to cereal, rye and triticale, there's some plus and minuses, pros and cons for each. Rye, for example, is very forgiving in the fall. You can plant it late. It sprouts fast. There's a high biomass, but it's less forgiving in the spring at harvest. If you're looking for forage to harvest, the window to capture high quality is very small. And if you have bad weather during that time, then you do not end up with good quality. So that is a challenge with rye. On the other hand, with triticale, it's less forgiving in the fall. You need to get it in earlier, but it's more forgiving in the spring. There's a wider window for harvest for high quality. And then there's some differences with seed costs as well that are pros and cons. Rye is generally less expensive than triticale. So I mentioned plot work. So we had a colleague here at the Dairy Forage Research Center that planted a lot of different combinations of both monocultures and 2- and 3-way mixes. And we settled for the feeding trial on 4 different mixes to evaluate, or 4 cover crops. One was the rye monoculture in the upper left-hand corner, and then the triticale monoculture. So those are straight, just rye and just triticale. And then we looked at a 3-way combination of rye, hairy vetch, and camelina, as well as a 3-way with triticale, vetch, and camelina. And we planted that. I forget how large the fields were, like 14, 15 acres, and so that we had enough for the feeding trial. And then we harvested it in the spring in boot stage. So these are some nutrient composition of the actual cover crops that at harvest time. And I think it's important to note that we didn't harvest these all on the same day. We harvested them in boot stage. So then as consequently, the nutrient composition, they're not identical. When we look at both the rye monoculture and the rye 3-way, you can see protein was about 13%, 13.5%, whereas the triticale, which was harvested, I think about a week and a half later, was actually slightly less in crude protein, about 11 or 11.5%. But the big thing to note is the NDF digestibility, and in this case, it's a 30-hour in vitro procedure. This is much higher than what we see in other forages. So these were all in this close to 70 or above 70, and that's what we see with the cereal grains for forages. And these are all like between 68 and 74, which is very high compared to corn silage, which is typically in the mid-50s, and alfalfa is usually around 42 to 45, sometimes a little bit higher. But when you're replacing forages that are lower in degradability or digestibility compared to these, we should see advantages of adding these into the diet. The other things were all similar across the board: sugar, starch. There's really no starch in any of these. And fat varied a little bit, but all about 5 to 6%. So similar in other fashions. So the experiment that we conducted, I was focused on looking at how can we include it in mid-lactation. And cows were roughly 60 to 150 days in milk at the start of the study. And we had 5 diets. So we had a control diet with no cover crops, which we would call a traditional corn silage alfalfa-based diet. Then we had the rye monoculture, the triticale monoculture, the rye three-way, and the triticale three-way, all included at 15%. And this was at a higher level than what people have done in the past with literature. But we wanted to kind of push the envelope a little bit. The goal was to feed for 8 weeks to determine the effects of the cover crop inclusion on both intake, the milk yield, milk composition, nutrient digestibility, and lastly, methane emissions. The picture that I have here is a picture of a green feed machine. And what happens is a cow sticks her head in there, and then when she's breathing into it, it actually records the breath, and you can actually determine how much methane she is exhaling. And so if there's differences in diets that results in differences in the fermentation in the rumen, we can understand more about how digestion works in the rumen as well as what she's breathing out. So that's I think, a valuable tool in understanding how we can more efficiently feed animals. Here are the diets. Oh, I try to make these really simple. Corn silage was at 30% and alfalfa at 30% in the control diet. So if we're looking on the left, we have 60% forage in the diets. And then all of the other ingredients, high moisture corn, 19%, canola meal, 5%, soybean hulls, 4%, roasted soybeans, which we roast right on our farm, is 4%, amino plus, which is a kind of a ruminal bypass type of soybean meal at 4%, and then some minerals and vitamins, 2.5. And the green feed pellet is the enticement to get the cow to put her head into the green feed. And we needed to use about 1.5% for that when cows weren't using the green feed, because we wanted to keep the diets identical for the entire study. So when you look across the board, as we added a cover crop, we simply decided the most similar crop would be alfalfa. So in this study, and contrary to the one in Pennsylvania, we did not replace corn silage. We left that the same. I didn't want starch to change, so that was identical. But we did take out alfalfa at 15%, and then all other ingredients stayed the same in this study. So very similar, with the exception of we needed to add a little more protein because alfalfa typically runs 22, 23% protein, and the cover crops were around 13%. So in order to make up that difference in protein, we added a little bit of more canola meal. And then as a replacement of adding that, we pulled out a little bit of soy hulls. But everything else, we tried to keep identical across the board. So we saw just small differences in feed ingredients. Here are the nutrient composition of the actual diets. So as a result, crude protein was for control about 16.8, and then for the cover crops, all about 16.3. Slightly less for the cover crops because of the replacement for alfalfa. Alfalfa was higher in protein, but they all met the nutrient requirement of a cow in like mid to late lactation. So these were still adequate and for protein. And then when you look at like starch in this particular case, we didn't change starch at all, either with corn inclusion or corn silage. So they were all about 24.5% protein, or sorry, percent starch. And so very consistent. I didn't want this to be a starch experiment. So this was all about keeping that the same. NDF does vary a little bit, but when you look across the board, they're all pretty similar at around 31%. So control being 29.5, and the highest one was the rye monoculture at 31.4, and the rest were in between the control and the rye. So all very similar. Ether extract, all very similar. Ash, all very similar. So we did this in late summer, early fall, got some preliminary results. This is what we have so far. So when we look at intake, and intake is really what drives milk production, we can see intake was all pretty much the same across the board and all about 53 pounds. The other thing I didn't mention was the 65 cows, about half of them were first lactation. Um, and so that's one reason why intakes are a little bit on the lower side, and about half were multiparous. So the multiparous cows, meaning second, third, fourth lactation, they are going to eat more, but the first lactation animals always eat less. So these are our average intake numbers for the entire group, and they're all around 53 pounds. So when we look at production, they averaged around 85, 86 pounds, and the NS means non-significant. So that means there weren't really any differences between any of the five diets here. When we look at fat percent, again, not significant, and all the animals are right around 4.1 to 4.2%. So we did this actually in this, July and August. So fat percent was pretty good for a summer experiment. Protein, again, protein, it's much more difficult to see big changes in protein because it's more genetic oriented, but we did actually see that the animals on the cover crops were slightly greater on milk protein, the average being, right around 3.08, 3.09 compared to control at 3.02. And then when you look at the triticale, the both the monoculture, meaning the triticale rye by itself versus the three-way, you can see the monocultures were slightly higher, about 3.10 versus 3.03, 3.04. Small differences in change, but we did see a small difference there. Total solids is simply fat, protein, lactose, all added together. And you can see when you look at those, uh, not significantly different. They're all roughly a little over 13%. Milk urea nitrogen, which I talked about being a part of protein utilization. There was a slight decrease in MUN for the cover crops, and that's simply related to the fact that crude protein of the diets were slightly less. Remember, they were like 16.2 versus 16.8. So that's a direct relationship. You feed less protein, MUN is typically lower. There is an interaction with starch. So if you have a lot of carbohydrate available, sometimes you can get changes in milk urea nitrogen based on both carbohydrate and protein in the diet, but it is still highly related to the amount of protein that you're feeding an animal. So if you get like an MUN that's like a 15, 16, 17, it typically means you're feeding highly degradable protein or a high level of protein in your diet. Sometimes they even can go in the 20s. I mean, it can be really high. But typically for our high production diets, we see lots of 10s, 11, 12s, 13s. So this is right kind of in the mix where we see it normally. A few other results, the yields, fat yield was about the same. Protein yield, we did for both protein yield, fat corrected milk, and the energy corrected milk. The energy corrected milk is simply taking into effect the weighting, the amount of protein and fat in the milk. And we do see that there are still differences between, like the control and the monoculture, but specifically the rye versus triticale, in this particular experiment, we saw slightly more energy corrected milk on the triticale based diets versus the rye based diets. And in part because the rye monoculture didn't perform quite as well as the rest of the diets. But when we express that feed efficiency, which is the per unit of energy corrected milk divided by per unit of dry matter intake, so on a pound per pound basis, you can see they're all identical all across the board, 1.75. So that means the cows were as efficient, including the cover crops, as they were on an alfalfa and corn silage based diet, which is actually good news. It means in the case where we need to use more unusual crops like these, and you have a situation where you can plant them in the fall, harvest them in the spring, and you need those for the summer to get you through the summer, then it shows that we can successfully incorporate those into the diet without detrimental feed efficiency effects, and really production and intakes were all about the same. So that's actually, I view that as very good news. So just briefly, a few conclusions. Different mixes and species of cover crops can really lead to greater soil benefits, resulting in improved forages for cattle. I think this is an area that is really being explored more extensively than in past years. So there's a lot of interest in this and looking at the relationship of soil health to the quality of the forages that we feed. And as I mentioned, there really are few feeding trials. So this study and the one you're going to hear next is going to add to the literature in understanding how we can successfully formulate diets with cover crops. This particular study demonstrated that we can include easily a 15%. I would venture to guess that we could go higher, especially in mid to late lactation cows, without really showing any detrimental effects. It does depend on the type of cover crops. So if you're using something, like we had some hairy vetch, if you add only hairy vetch, there are some potential negative effects with high hairy vetch diets. You can't do that because there's some anti-nutritional factors. But at very low levels of inclusion, there could be advantages with the soil health, which then we can still feed if they're low levels of inclusion. So the types of cover crops and mixtures really need more investigation and understanding how it fits into the dairy system of looking at soil, forage, cow. And I think more work in this area will be an advantage in understanding how we can make optimal mixtures and how we can include that into the diets in the future. So with that, that's it. That's my end. I'm happy to take any questions later on. I think we're doing that all at the end.
Yeah, thank you, Dr. Kalscheur. This was very interesting information. And yeah, if you're sticking around, we'll take any questions in the chat box as we transition to our next speaker.